All right, welcome. Today we're going to be going through the 2015 paper 2, nice and easy. So question 1. Question 1 start by telling you that let P and Q be two propositions, and it says state the inverse and the contrapositive of the statement P implies Q. All right, so you have the statement. They give you the conditional statement. The conditional statement is given as P implies Q. P implies Q. That's the conditional. So to write down the inverse is just not P implies not Q. Not P implies not Q. That's the inverse. And then they also ask for the contrapositive. They ask for the contrapositive. And remember, the contrapositive is logically equivalent to the conditional. So this is the contrapositive. Contrapositive is not Q implies not P. That is the contrapositive. Nice and easy. Not Q implies not P. All right, so now we gave them the conditional, we gave them the inverse, and we gave them the contrapositive. And we know that the conditional is logically equivalent to the contrapositive, and also the inverse is logically equivalent to the converse. All right, we know those things. Nice and easy. All right, let's look at the next part of the question. So this is part 1. Nice and easy. The next part says copy and complete the table below to show the truth value for P implies Q and not Q implies not P. So they're pretty much asking you to show that the conditional is logically equivalent to the contrapositive. Let's go ahead and do that. Show that So first let's complete the table. Let's put the table here. We have our two propositions, P and Q. Then we have not P in this column. Then we have not Q. Then we have P implies Q. And we have not Q implies not P. So this takes care of all of them. All right, excellent. So we have P, we have Q, we have not P, we have not Q, we have P implies Q, and we have not Q implies not P. The good thing is they already filled out the table for us with the truth values for P and Q, which makes it very easier. So you have true, true, then false, false. Then you have true, false, true, false. Now you want not P. What's going to be not P? Not P is when you negate P right here, the negation of true, let's put it in burgundy. The negation of true is false. The negation of true is false. The negation of false is true. The negation of false is true. For not Q now, the negation of true is false. The negation of false is true. The negation of true is false, and the negation of false is true. Good. Now for P implies Q. P implies Q is false only when P is true and Q is false. So if P is true and Q is false, then P implies Q did not take place. So this is the only time P implies Q is false. Everywhere else it is true. All right. And then not Q implies not P. Not Q implies not P is false whenever not Q is true, but not P is false. That's right here. And so this is the only time it is false. Everywhere else it is true. All right, so that's that. So what does this mean then? This means that, as we can clearly see, that from these two truth results, from the column of the truth results, we can see that P implies Q and not Q implies not P. Since they have the same truth values, then clearly we can say that they are logically equivalent. All right, so this is just the truth table for part 2. Let's look at what part 3 asks. Part 3 says, hence, state whether the compound statements are logically equivalent. Yes, they are logically equivalent. So let's state that here now. So part 3. All right, let's fit part 3 up here. Hence, from the truth table results, we can see that P implies Q. P implies Q is logically equivalent. P implies Q is logically equivalent to not Q implies not P. Nice and easy, soft. From the truth table, we can clearly see this. All right? Clearly, from right here, they are the same. All right, so you can put it right here, the same. All right, nice. Now let's look at part B. Part B, all right, let's go to part B. Part B says that the polynomial f of x is equal to x cubed. F of x is equal to x cubed plus px squared minus x plus q. Let's write that down. F of x is x cubed plus px squared minus x plus q. This is f of x, all right? And it says it has a factor of x minus 5 and a remainder of 24 when divided by x minus 1. So what they're telling you is that f of 5 is equal to 0 since x minus 5 is a factor. So if f of 5 is equal to 0, you can plug in 5 into the function to get 5 cubed. So we work out what is 5 cubed. I believe that's 125. So 5 cubed, that's 125. Plus 5 squared is 25. So we get 25p. Minus x is 5 right here. So we have minus 5 plus q. And this is equal to 0. You can just set up your equation from this now. So set up your equation. All right, so as you can see, it is 25p plus q. That is equal to 125 minus 5 is 120. And when you bring it over to the other side, it's minus 120. All right, so we have one equation right here. Now let's go ahead and look at the second equation. The second equation that we're going to generate, it says it has a remainder of 24 when divided by x minus 1. So what they're telling you then is f of 1 is equal to 24. That's the remainder. So since f of 1 is equal to 24, we're good. All we need to do is substitute x as 1 into the equation, and we're going to get 1 plus 1 square is 1, so you get 1 plus p minus 1 plus q, and that's equal to 24. All right, this is equal to 24. But then you have to remember that 1 minus 1 cancel each other. And so this equation is just telling us that p plus q is equal to 24. P plus q is 24. You can go ahead and then just subtract these two equations that you've generated. And by subtracting these two equations, you're going to get 25p minus p is 24p. Subtracting them, q minus q that gone. Minus 120 minus 24 is minus 144. You can then divide through by 24. And so what do we get? Therefore, p is equal to minus 144 divided by 24. And so we get p equal negative 6. So p is equal to negative 6. Nice and easy. Now that we get p is negative 6, we can go ahead and substitute back into any one of these equations to find what is q. All right, so since p is negative 6, I'm going to plug it into this one. All right, p plus q is 24, and so q has to be 30, because 30 plus negative 6 is 24. So that implies that q is equal to 30. All right, so we found the values of p and q. Nice, so p is negative 6 and q is 30. No issues, soft. And you can always check back your answer just by substituting p as negative 6 and q as 30. Test to see if f of 5 is 0 and f of 1 is 24. You can check it. It's always good to just check your answer to make sure that you didn't make any mistake. All right, so we're fine. Now the next part says factorize f of x completely. To factorize f of x completely, all right, we're going to write f of x is equal to, we can replace p now with the value that we know, so it's going to be x cubed. Instead of plus px, it's minus 6x squared, minus 6x squared, minus x, plus q, and q is, we said q was 30, so we have plus 30. All right, now we need to factorize this expression. We already know that it's going to be 3 linear factors, right? We know it's going to be 3 linear factors, all right, because it's a cubic expression. Now look how we're going to find the other linear factors. We don't want to be doing polynomial division all the time. That takes up too much time sometimes. Utilize some other knowledge. So we know that x minus 5 is a factor. So we need the other 2 factors. So I'm going to put a here and b here. All right, and I'm going to put x minus a and x minus b for now. So we're going to find what is a and what is b. So you might say, sir, what are we doing? We're using up some other knowledge. We're using sums and products of roots. The sum of the 3 roots is 6. And so we can write that the sum of 6 must be equal to 5 plus a plus b. 6 must be equal to 5 plus a plus b. The sum of the 3 roots right here, which is 6, must be equal to 5 plus a plus b. And so 1 is equal to a plus b. All right. The next thing is that, all right, next thing we know is that the product of the 3 roots is 30 minus d over a, so it's negative 30. So the product of the 3 roots is negative 30. So that means say 5 times a times b is negative 30. All right, so 5 times a times b is negative 30. If I divide through by 5, then negative 6 is equal to a times b. All right, so now I can just solve these equations simultaneously. All right, it's just easier than to do the polynomial division in my estimation. Or you can just look at it. Which two numbers, when you add them, you get 1. When you times them, you get -6. All right, you can just look at it and determine. In my estimation, we work it out. So -6 is equal to, replace A or B by making one of these the subject. I said that A is 1 minus B. So this is 1 minus B times B. 1 minus B times B. 1 minus B times B is just, this is working out to be B minus B squared, B minus B squared, B minus B squared, and this is -6. And so all I have to do is bring it over now, and I get B squared minus B minus 6. B squared minus B minus 6, that's equal to 0. Then I factorize it. Signs are different and the greater number is negative. Right? And so what I'm getting is B and B, 3 and 2. Signs are different. The greater number is negative, so I put a negative here and a plus here. And so B is -2, or B is -2, or B is 3. All right. So if B is -2, then I automatically get what is A. All right. If this is -2, if you bring over -2, you get A is 3. All right. And if you put right here now, if B is 3, then A is -2. All right. Nice and easy. Nice and easy. All right. So now we can just replace it right here now. And so A is 3. A is 3. So it's x minus 5 times x minus 3. And this B now is -2. So it is x plus 2. X plus 2. All right, and we did it using sums and products of roots. All right, so make the examiner know that you know what you used to do it, to tell them, say, using sums and products of roots. Stop doing polynomial division all the time. It's so boring to always be doing polynomial division. So using sums and products of roots, we factorized it. All right, nice and easy. Soft. Let's look at the next part of the question. Part C. Part C now we're going to be doing using mathematical induction. So let's go. Part C says, given that Sn is equal to, let's say Sn is equal to 5 plus 5 squared plus 5 cubed, plus we keep on adding all the way down to 5 to the n. This is Sn, right? So in other words, I'm going to rewrite Sn. I am going to rewrite Sn as the sum from r equal 1 to n of 5 to the r. That is Sn. In other words, Sn is the sum from r equal 1 to n of 5 to the r. All right, and they want us to show that, so they want us to prove, this is what they want us to prove. They want us to prove that 4Sn, so they want us to prove that 4 times the sum from r equal 1, 4 times the sum from r equal 1 to n of 5 to the r is equal to 5 to the n, 5 to the n plus 1 minus 5. This is what they want us to prove, that 4 times 5 to the r is equal to 5 to the n plus 1 minus 5. So let's go ahead and prove this, all right? Again, to prove this, you start with your 3 cases. You start with n is equal to 1, all right? When n is equal to 1, the left-hand side is going to be equal to the sum from r equal 1 to n, which is the sum from 1 to 1, all right, of 5 to the r, which this is just 5. So this is going to be 4 times 5. Another way to look at it is when r is equal to 1, this is it. N is equal to 1, it's just 5, just the first term. 4 times 5, which is 20. That's the left-hand side. All right. Then the right-hand side is going to be, all right, now we have this now, right-hand side, put in 1, it's going to be 5 squared minus 5. 5 squared minus 5 is still 20. And so n equal 1 is true. So therefore, n equal 1 is true. N equal 1 is correct. So now we need to do is assume n equal k is true. That is step 2. Assume n equal k is true. So let me split right here. We're going to do step 3 over there. So step 2, assume n equal k is true. All right. So let n equal k. When n is equal to k, what we're getting is 4 times the sum from r equal 1. 4 times the sum from r equal 1 to k, because n is now k, of 5 to the r. And that is going to be equal to, 5 to the k, n is k now, so it's 5 to the k plus 1 minus 5. All right, and again, you assume that this is true. Assume it is true. Assume n equal k is true. Assume that it's true. All right. Now let's go to step 3. Step 3 now, we need to show that n equal k plus 1 is true if n equal k is true. For n equal k plus 1, what we're going to get is 4 times. We're supposed to get 5 to the k plus 1 minus 5. So pretty much we need to get 5 to the k plus 2. All right, we need to get 5 to the k plus 2. So now for n equal to k plus 1, we're going to have that. We have 4 times the sum from r equal 1 to n of 5 to the r, n equal k plus 1, sorry, why am I writing n? N is k plus 1, so don't write the n, write k plus 1. So it's 4 times the sum from this, so r equal 1 to k plus 1 of this, all right? That's going to be equal to the sum from 1 to k. Remember, it's equal to the sum from 1 to k. So it's going to equal to the sum from r equal 1 to k of f of r of 5 to the r plus the k plus 1th term. The k plus 1th term is going to be you putting k plus 1 over here. So the k plus 1th term is going to be 4 times, putting in k plus 1 here, it's 5 to the k plus 1. That's the k plus 1th term, all right? And so what this is working out to be now is the sum from 1 to k of 5r. We said that it's right here. It's 5 to the k plus 1. So it is 5 to the k plus 1 minus 5 plus 4 times 5 to the k plus 1. All right. Now look at this. You have 5 to the k plus 1 plus 4 times 5 to the k plus 1. So that is just 5. That's just 5 times 5 to the k plus 1. All right, you have one donut. and you have 4 donuts. You add them and you get 5 donuts. So it's 5 times 5 to the k plus 1 minus 5. Now, according to laws of indices, this 5 is really 5 to the first power. So it's really 5 to the first power being multiplied by 5 to the k plus 1 minus 5. Now, whenever the bases are the same, we can add the powers. So whenever the bases are the same, we add the powers. So this becomes 5 to the k plus 1, 5 to the k plus 1 plus 1. So it's 5 to the k plus 1 plus 1. We add the powers, minus 5. And so therefore, n equal k plus 1 is true. So we can write our conclusion now. Therefore, n equal to k plus 1 is true if n equal k is true. Nice and easy, soft. So what do you finally conclude? Finally, you can conclude that hence, by principles of mathematical induction, the statement above is true for all natural numbers. Nice and easy, soft. The statement above is true for all natural numbers. Nice and easy, soft. And that takes care of question number 1. Too easy. Let's move on now to question 2. Question 2 says, the relation f is such that it maps set A to set B and set G is being mapped from set B to set C. They are functions which are both one-to-one and onto. Show that G of f is one-to-one and onto. So there are 2 ways we can really do this proof. All right, so let's write down what they say. They tell us that the function f is such that it maps set A onto set B. All right, and the function A maps to set B, and the function G is such that it maps set B onto set C. And so this is what we know. So what's going to happen? So G of f, that function is going to be such that it maps set A, where is G? G is this one. So G of f, putting f into G, okay. So G of f is going to map from B to C first, all right. So let me start it with this proof then, the function G of f. All right, so what I'm going to do is I'm going to do it by example, right? You can do it by example. Give f some values then, give f some values. So you can give f the set. Maybe you can make f be, let's make it easy and write P, Q, R. This is in the set A, and in the set B, we have maybe 1, 2, 3. All right. Let this be the function f. All right, doing it with the example. And they said that f is one-to-one and onto. All right, so let's make P map to 1, Q map to 2, R map to 3. All right, this is f. Let this be f. All right, and then G now, we can make G be something like, well, B is going to be 1, 2, 3. All right, 1, 2, 3. And it's mapped to some new set C. We can let set C be maybe A, B, C. All right, let's set C be A, B, C. So 1 will map to A, 2 will map to B, and 3 will map to C. All right, so G is also one-to-one and onto. Remember, they said that. So this is the function g. All right. So now they want g. What did they want? I think they want g of f. They want g of f. So they want us to put f into g. So g of f. So they want g of f. All right. So g of f is what they want, which they want us to put f into g. So we're on the domain of f. So g of f is pretty much this. G of f is going to be putting in f into g. So this is what you're having. You're applying f first, and then you're going to apply g. All right, you're applying f first, and then you're going to apply g. So you have, this is a, this is set b, and this is set c. All right, and so applying that, you're going to have p, q, r, set b, which is we defined as 1, 2, 3, and set c, which is a, b, c. All right, so p maps to 1, q maps to 2, r maps to 3, 1 gonna map to a, and 2 gonna map to b, and 3 gonna map to c. And so in reality, g of f is such that it's just mapping set a to set c. That's what g of f is doing. It's just mapping set a to set c. So finally gonna write it down here that this is g of a. G of f is this. So g of f is p, q, r, and it's being mapped to a, b, c. All right. This is using examples, and so hence as we can see, so we can make our conclusion now. Let's write the conclusion over here. Conclusion. So hence g of f is 1 to 1 and onto on the domain of f. It's always on the domain of f. All right, as we can see, it is 1 to 1 and it is onto, but it's on the domain of f. All right, it's on the domain of f, and you can even add a little further note. You can say as g of f will map set a onto set c. All right, that's what g of f do. That's one way of doing it. Now let's look at the alternate method right here, or. Right, let's look at alternate method, or. That's one way to do that question. The alternate method is you're going to do a lot of discussion. We're going to show them that we have our knowledge about functions, right? So using your knowledge, since you know that you have your knowledge of function, it told us that f is 1 to 1 and g is 1 to 1, comma, so the composite function g of f will be on the domain of the inner function. It will be on the domain of the inner function f, put in bracket, that is set a. And since both f and g are 1 to 1, then g of f will also be 1 to 1 but on the domain of the inner function f. Hence, g of f is 1 to 1. Right? This is if you wanted to show them that you have your functions knowledge, you know what you're talking about. It's always on the domain of the inner function. So you can tell them that. All right, nice and easy. All right, soft. You can go ahead pretty much and tell them the same for onto. You can tell them that f is onto. So you can tell them that f is surjective. F is surjective and G is surjective. Right? And so the composite function GF will be on the domain of the inner function f, that is set A. And since both f and g are surjective, because remember that's what onto means, surjective, then g of f will also be surjective. But on the domain of the inner function. Hence, g of f is onto. Right? Nice and easy, soft. All right, that takes care of the first part of this question. All right, this functions question, nice and easy, soft. All right, let's look now at what's happening with the next part of the question. Part 2. Part 2 says solve the following equation. So we have some equations to go ahead and solve. So we're going to solve 3 minus 4. So part A, we're solving 3 minus 4 over 9 to the x. 3 minus 4 over 9 to the x minus 4 over 81 to the x. And we're solving this equal to 0. Now the first thing I want to do is I want to rewrite this equation as, rewriting it as 3 minus 4 over 9 to the x minus 4 over, instead of saying 81, I'm going to rewrite this as 9 squared, and 9 squared to the x is just 9 to the 2x. And that's equal to 0. So what I'm going to do is I'm going to multiply this equation by 9 to the 2x. So I'm going to multiply through this equation by 9 to the 2x. By multiplying this equation through by 9 to the 2x, what I'm getting is this becomes 3 times 9 to the 2x. And remember, 9 to the 2x can be written as 9 to the x all square by laws of indices minus, this is going to become 4 times 9 to the x. And then this is just going to become minus 4 is equal to 0. All right. Nice. All right. Now what you can do is you can call that y. All right. You don't have to call it y. You can just factorize it. But let's say you prefer to call it, let y be equal to 9 to the x. You can do that, let y equal to 9 to the x. And so you're getting 3y squared minus 4y minus 4 is equal to 0. Now you can go ahead and factorize it. So you can factorize it now, and what you're getting is, if it is 3y squared minus 4y minus 4 equal to 0, signs are different, the greater number is negative. So we have 3y and y. The bigger one is negative, so this 2 is minus, this is plus, this has to be 2 as well. Let's check it out. This time this is 3y squared. This time this is minus 6y. This time this is plus 2y, which give us back minus 4y. So we're good. So in this case, we're getting that y is equal to, from right here, y is minus 2 over 3. And if y is minus 2 over 3 here, and here we're getting y is 2. But let's just bear in mind that we know that y is 9 to the x. All right, we know that y is 9 to the x. So really and truly what we're solving is 9 to the x. Let me make some space here. So really and truly what we're solving is 9 to the x is equal to negative 2 over 3. Now you cannot have a number and raise it to a power and get minus 2 over 3. So you can tell them that this is crazy. You can tell them that this is crazy. This is crazy. That's crazy. All right, this is crazy. You can't raise a number to a power and get a negative answer. So you can throw that away. So the only part we'll focus on is the 9 to the x being equal to 2. If 9 to the x is equal to 2, well, we can take logs of both sides. By taking the log of both sides, we can get that x log 9, right? Using laws of logarithm, x log 9 is equal to the log of 2. And so we divide both sides by log 9 to write that x is equal to log 2 over log 9. And so we find x is log 2 over log 9. And then you put that in a calculator, log 2 divided by the log of 9, and so you get 0.315. So that is x. X is 0.315. 0.315. That is x. All right, nice and easy, soft. Log 2 over log 9, which is 0.315. Okay, now let's look at the second part of the question. The second part of the question, it says that we are supposed to solve the modulus of 5x minus 6, and we're supposed to solve that equal to x plus 5. So let's go ahead and do that. We're solving the modulus. We're solving the modulus of 5x minus 6. We're solving that, and that is equal to x plus 5. There are two ways you can do this question. If mod A is equal to B, then we know that 5x minus 6 is equal to x plus 5. Or we know that 5x minus 6, we know that that is going to be equal to minus of x plus 5. It's one of the two. And so it works out that to be, if we subtract x over here, subtract x, we get 4x. And then we add 6 to both sides, we get 4x equal 11. Divide through by 4, we get x is 11 over 4. That's one answer. Over here now we have or. If this becomes minus x, so bring it over here, it becomes 6x is equal to, we have minus 6 here. So we bring over the minus 6. If we bring over the minus 6, we're going to get, adding 6 to over here, 6 minus 5. 6 minus 5 is 1. So you have 6x is equal to 1. And so what you're getting then is x is equal to 1 over 6. All right. So that's what you get right there. All right. Nice and easy. So those are the possible solutions. X is equal to 11 over 4, or x is equal to 1 over 6. When you finish, you just want to test your answer. Always test it. Always test it. So this is how you test it. Test. You need to check. Let's start with when x is 11 over 4. When x is 11 over 4, you need to plug it in here to see if the mod of 5 times 11 over 4 minus 6, that will work out to be, so testing that, it works out to be 5 times 11 over 4 minus 6. That's 7 3/4. That's 7.75. Let's test if we get the same over here. Yes, we're going to get the same over here. 11/4 plus 5. That is indeed equal to 7.75. And so 11/4 is good. Let's check when x is 1/6. When x is 1/6, what you do now is when x is 1/6, you put it in here and you have the modulus of 5 times 1/6 minus 6. The modulus of that is equal to, you put it in here, put it in a calculator, 5 times 1/6 minus 6. The modulus of that is 5 and 1/6. So that's 5 and 1/6, which is 5.167. All right, and on the right hand side, it's gonna be 1/6 plus 5, which is the same as 5.167. And so both answers are correct. So both answers are correct. All right. That is, x is equal to 11/4 or x is equal to 1/6. Now, there's always an alternate method to doing these questions. You didn't have to go by this direct method. All right. What you could have done is square both sides, which is the popular choice. The popular choice is to square both sides, where what some persons would do is square both sides to get 5x minus 6 all square. 5x minus 6 all square is equal to x plus 5 all square. All right, this is just the alternate method, which I wouldn't recommend. Right, this is just wasting time. I recommend the first method. Then you expand the square, first term square, which is 25x squared, minus twice the product of the two. 6 times 5 is 30, so that's minus 60x, plus second term square. Second term square is plus 36. Then you expand the square over here, it is first term square, which is x squared, twice the product of the two, which is 10x, plus second term square, which is 5 squared, which is 25. Nice and easy. After you do that now, you bring over your x squared over here, so you get 24x squared, 24x squared. Bring over the 10x over here to get minus 70x. Then you bring over the 25 over here to get plus 11. That's equal to 0. I expand this, right? 25x squared minus 60x plus 36. Yes, this is expanded correctly. So now is to just go ahead and factorize this, or you could just use quadratic formula from here. Go ahead and use quadratic formula. All right, you could just use quadratic formula from here, and you could get that x is going to be equal to 70 plus or minus the square root of b squared minus 4ac. When I work that out, that will be 70 plus or minus 62 over 2a. 2 times 24 is 48. As you can see, the two answers you're getting are 70 plus 62 divided by 48. You're getting the 11/4. So in this case, you're getting x is 11/4, or you're getting x is 1/6. All right, nice and easy. So anyway you take it, you're getting the two answers, them 11/4 or 1/6. So you can either use it by, squaring both sides, or you can remember this rule. This is the rule that you need to remember. If the modulus of A is equal to B, then A is equal to minus B, or A is equal to B. So that's the rule that you need to remember, right? That's the modulus rule. Very easy to remember, soft. All right, let's continue now. Go ahead and look at the next part of the question. The next part of the question says, the growth of the population or the growth of bacteria in a river after time t is given by n is equal to 300 plus 5 to the t. All right, so let's write that down. The number of bacteria in a river is given by n is equal to 300 plus 5 to the t. N is equal to 300 plus 5 to the t. All right, that is n. So now the question that they're asking is, find the number of bacteria present when t is equal to 0. All right, so when t equals 0, we're going to substitute in t into this equation. When t is 0, we plug in t is 0, and so we get n is equal to 300 plus 5 to the 0, and anything to the 0 power is 1, and so n is equal to 301. That's the first part. Nice and easy. Soft. N is 301. Now let's go to the second part of this question. The second part in this question now, it says that find the time required to triple the number of bacteria. So initially, there is 301 bacteria, and we need to find the time that the bacteria will be tripled. So in part 2, a tripling of the bacteria, if you triple 301, so it's 3 times 301, that's when the bacteria is tripled. 3 times 301, 300, 3 times 301, and we're going to set that equal to 300 plus 5 to the t. And we're going to find out in how many, t is in hours, we're going to find out in how many hours it takes the bacteria to triple. All right, so we expand this, and so we're getting 903 is equal to 300 plus 5 to the t. And so all we have to do now is subtract 300 from both sides. Subtracting 300 from both sides, we get 603 is equal to 5 to the t. So to solve for t now, all you need to do is take log of both sides. So we're going to take the log of both sides, and so the log of 603 is going to be equal to the log of 5 to the t, log of 5 to the t, but by laws of logarithm, we can bring down the t. So let's write it as t log 5, write it as t log 5, and so t is going to be equal to log of 603 divided by the log of 5. That's how we find t, the log of 603 divided by the log of 5. So you put this in a calculator to work out what is the log of 603. Log of 603 divided by the log of 5, and I'm getting 3.977. Always round off to 3 significant figures, so that's 3.98 hours. So it's taking roughly, so you can give them a statement. It is taking roughly 4 hours. It is taking roughly 3.98 hours. And if you want to convert it to minutes, 0.98 times 60. So in reality, it is taking roughly 3.98 hours. That is, it is taking 3 hours and 58. It's taking 3 hours, 58 minutes, and and 48 seconds. It's taking roughly 3 hours, 58 minutes, and 48 seconds for the number of bacteria to be tripled. That's what is happening. So in conclusion, so I would say in my estimation, the river is very polluted. Is very polluted. All right, this is a very polluted Caribbean river. Very polluted. Very, very polluted. A little too polluted. All right. All right. Very, let's go. So that takes care of module 1. All right. Now we get to go on to module 2. Module 2 now, we know question 3 generally is trigonometry. Module 3 says show that cosine 3x is equal to 4 cos cube x minus 3 cos x. That's what we need to do. All right. So first thing, I like to start with left-hand side. So as you know, our left-hand side is approximately equal to, it says cos 3x. Cos 3x. All right, this is our left-hand side. Now, as we know, cos 3x is equal to, we can rewrite that as the cos of 2x plus x. This is cos 3x, the cos of 2x plus x. But then we know what is the compound angle formula for this. Cos 2x plus x is given by, this is given by cos 2x cos x. This is given by cos 2x cos x minus sin 2x sin x. Minus sin 2x sin x. Aha. But then now, we realize that we reach where we need to use the double angle formulae. The double angle formulae for cos 2x, there are three of them. You know, you have 2 cos square x minus 1. You have 1 minus 2 sine square x. And you have cos square x minus sine square x. Which one will you use is up to you. I will use 2 cos square x minus 1. Why? Because I'm multiplying it by cos and I want everything to be in terms of cos. So I'm going to write 2 cos square x, 2 cos square x minus 1. That is a double angle formula for cos 2x. And it is being multiplied by cos x. All right, nice and easy. It's being multiplied by cos x. Minus sine 2x as you know it. Sine 2x is 2 sine x cos x. So we have 2 sine x cosine x, 2 sine x cos x, and that is being multiplied by sine x. Nice and easy. This is being multiplied by sine x. And so what we do now is we expand out these now. Expanding through, we're going to get 2 cos square x times cos x. That's going to give us 2 cos cube x. This is 2 cos cube x minus cos x times 1 is cos x. All right, cos x times 1 is cos x. Then minus, now 2 sine x cos x times sine x becomes sine square, because sine times sine is sine square. So it becomes 2 sine square x, 2 sine square x times the cosine of x. Now here's where the trouble comes in now, because we have everything in terms of cos, but then we have this sine square right here. But sine square is 1 minus cos square. So let's go ahead and write that. Sine square is 1 minus cos square. So this is going to become 2 cos cube. This becomes 2 cos cube x minus cos x. And then we replace the sine square here with 1 minus cos square. So it becomes 2 times 1 minus cos square x. 1 minus cos square x, and it's still being multiplied by, of course, cos x. So all we need to do now is expand over here. So we need to expand it, and when we expand it, what we're going to get is 2 cos cube x, 2 cos cube x minus cos x, 2 cos cube x minus cos x. And when we expanding this now, we have minus 2 times 1 is minus 2. But then it is minus 2 times cos x, which is minus 2 cos x. Remember, we're multiplying. We multiply the minus 2 times the 1, and then we multiply the minus 2 times the cos x to get minus 2 cos x. Then the minus 2 times the minus cos square is plus 2 cos square, and then plus 2 cos square times cos x becomes plus 2 cos cube, plus 2 cos cube x. All right, nice and easy. And so now we have 2 cos cube x plus a 2 cos cube x. When we add those two together, what we're getting is 4 cos cube x. This becomes 4 cos cube x, 4 cos cube x. And then what we have now is minus cos x minus 2 cos x. Those two together becomes minus 3 cos x. Is that what we have? I'm sure that is what they want us to prove. Yes, that is what they want to prove. And that is equivalent to our right-hand side. Nice and easy, soft. That's equivalent to your right-hand side. So you can just write down easily brushed aside. Easily brushed aside. Right. Nice. So good with this question. No issues whatsoever. Let's look at part 2 now. Part 2 now we have that hence or otherwise solve cos 6x minus cos 2x. So we need to solve cos 6x, solving cos 6x minus cos 2x. Solving cos 6x minus cos 2x, and we're solving that equal to 0. Solving cos 6x minus cos 2x equal to 0. All right. And it says hence. Hence means we're going to utilize the knowledge that we have from above. Now, since it says hence, the only thing I can see is that I can separate cos 6x. Well, I'm not even going to use the hence. We can use hence, but I'm going to go with otherwise because I know that this is the difference of 2 cos. You could go with hence by separating this as cos 4x plus 2x, and then you know that cos 4x from around here is 4 cos cube x minus 3 cos x. But I don't want to go that route. That seems more tedious. I'm going to go this route. The route I want to go is this route. The route I want to go is this route where I'm going to use that the difference of 2 cos is given by minus twice the sign. So it's minus twice the sign of half the sum. So it's minus sine of half the sum, which is 6x plus 2x divided by 2 times the sine of half the difference, which is times the sine of half the difference. Half the difference is 6x minus 2x over 2. And that is, of course, equal to 0. Nice and easy. So now what we're getting then is, if we divide through by minus 2, we're going to get that the sine of 6x plus 2x is 8x. 8x over 2 is 4x. That becomes the sine of 4x. Then the sine of, now 6x minus 2x is 4x. 4x over 2 is 2x. This becomes sine 4x times sine 2x. Of course, you had the times the minus 2, and this is equal to 0. So if this is equal to 0, the only way this can be equal to 0, it can't be the minus 2 fault make it be 0. So it must be that sine 4x equals 0 or sine 2x equals 0. So all we have to do now is write that down. So it's either sine 4x is equal to 0. So it's either sine, why is it still in caps? Sine 4x is equal to 0 or sine 2x is equal to 0. That's what we have. It's one of those two. Now, if it is sine 4x equal to 0, then this is, you can draw a circle. Draw a circle for me. All right, and split up your quadrants. Split up your quadrants. All right, if sine 4x is equal to 0, 0 is in the first quadrant, so your principal acute angle is going to be sine inverse of 0, which is 0. Sine inverse of 0 is 0. All right, always remember that sine inverse of 0 is 0. All right, but then remember sine is positive in the first quadrant and sine is positive in the second quadrant. So what you're getting then is 4x is equal to 0 or 4x is equal to pi minus 0, which is pi. But remember now you know that since it is 4x, you want your answer to be between 0 and 2 pi. So you can spin around the circle one more time to get that. If you go around the circle one more time, you're going to get 2 pi plus 0, which is 2 pi. You have to go around the circle one more time. All right. And you go around the circle one more time to get the 2 pi plus pi is 3 pi. So you're going to get 3 pi. All right. Now let's see. Since it has 4x here, I think we can spin around the circle 4 times. So let's go around the circle another time. This is going to be the third time. Going around the circle again, you have 2 pi plus pi. 2 pi plus pi is 4 pi. So 4 pi can be a part of the solution. And then this 3 pi plus 2 pi is 5 pi. So go around the circle 3 times so far. Let's go around the circle 4 times now. Going around the circle the 4th time, all right, we're going to get this 4 pi plus 2 pi is 6 pi. All right, that's 6 pi. And then this 5 pi plus 2 pi is 7 pi. All right, and let's go around the circle one last time, a 5th time. Going around the circle one last time, what we're going to get is 6 pi plus 2 pi is 8 pi. And 7 pi plus pi is 9 pi. So these are all the possible values for 4x. Now we're going to divide through by 4. So dividing through by 4, that implies that x is equal to 0 over 4, comma, pi over 4, pi over 4. 2 pi over 4 is going to be pi by 2. So we can write that pi by 2. Then 3 pi over 4 is going to be 3 pi by 4. Then 4 pi by 4 is going to be pi. That's going to be pi. Then 5 pi over 4, that's going to be 5 pi by 4. Then we're going to have 6 pi over 4, which is 6 pi by 4. And 6 pi by 4, yeah, let me just write it as 6 pi by 4. Can simplify it a little bit more, but write it as 3 pi by 2. Then you're going to have 7 pi by 4. All right. And then after you have 7 pi by 4, you're going to have 8 pi by 4, which is 2 pi. But we can stop right here. We can stop right here. Why can we stop right here? Because 9 pi by 4 is going to be bigger than 2 pi. So this one is not valid. So this one is not valid. That one, not valid. All right. So those are all the values of x we get from this solution. Let's solve sine 2x equals 0 now and look at the solutions we're getting. So for the next part, we're solving sine 2x is equal to 0. Solving sine 2x equal to 0. Again, the two possible answers that we're going to get is 2x is equal to 0 or 2x is equal to pi. All right. Now we can go around the circle one more time. By going around the circle one more time, we're going to get 2x is equal to, going around the circle one more time, we get 0 plus 2 pi, which is 2 pi. All right, we can go around the circle one more time to get 4 pi, and then we stop there. And from over here now, we can go around the circle one more time to get that 2x is equal to, go around the circle one more time, you have pi. The next thing you're going to have is 3 pi. So you divide through by 2 now. Divide through by 2. And so from this part of the solution, we're getting x is equal to 0, or 2 pi over 2 is pi, or 4 pi over 2 is 2 pi. And from this side, you're getting that x is equal to, divide by 2, you get pi by 2. And divide by 2, you get 3 pi by 4. Now, all of these answers that we get right here, these are already in the solutions up here. And so this is the final answer up here. All of these are the final answers. All right, all of these is the final answer. All right, so that's the answer. 0, pi by 4, pi by 2, 3 pi by 4, pi, 5 pi by 4, all of that stuff. That's that. Nice and easy, soft. Now let's go to the next part of the question. The next part of the question, part B. Part B, it is saying that we need to express f of 2 theta in the form 3 sine 2 theta plus 4 cos 2 theta. That's f of, this is f of 2 theta. So f of 2 theta is equal to, f of 2 theta is equal to 3 sine 2 theta, 3 sine 2 theta plus 4 cos 2 theta. We need to express it in the r sine form. So in order to express it in the r sine form, the first thing we have to remember is that r is equal to the square root of a squared plus b squared. So r is going to be equal to the square root of 3 squared plus 4 squared, square rooted. All right, so when you work that out, you're going to get 5. That is r. And the next thing we need to find is alpha. Alpha is going to be tan inverse of b over a. That's alpha. Alpha is tan inverse b over a, which is tan inverse of 4 over 3. Tan inverse of 4 over 3, we can work that out. So we get in tan inverse of 4 over 3. Tan inverse of 4 over 3 is 0.927. That's tan inverse 4 over 3, 0.927. All right, that's tan inverse of 4 over 3. All right, nice. Alpha, tan inverse 4 over 3, good. So now we can finally put it in the correct form. F of 2 theta, and so f of 2 theta is equal to 5 sine, so it's 5 sine 2 theta plus alpha, so it's 5 sine 2 theta plus 0.927. All right, that's f of 2 theta. Nice and easy, soft. That's f of 2 theta. They're giving away 6 marks to do this. I don't know why, but they gave us 6 marks and we have it done and dusted. All right, nice and easy. The next part says hence or otherwise, find the maximum and minimum values of 1 or 1 minus 7 f of theta. Now, first thing we can start with is that f of theta will be bounded between, and I think that should have been f of 2 theta. F of theta will be bounded between r and minus r. R is 5, so f of theta is bounded between 5 and minus 5. Then what we can do next is divide through by minus to get that minus f of theta. Anytime you do division by minus 1, you change the sign. All right, so it becomes minus 5 by minus 1 is 5, and then 5 divided by minus 1 is minus 5. So this is minus f of theta. Then we add 7 to both sides to say that 7 minus f of theta, 7 minus f of theta will be bounded between, be less than or equal to, add 7 to both sides. 7 plus 5 is 12. 7 plus minus 5 is 2. All right, and then we now reciprocate it. When you reciprocate it, the signs will change again. So the signs will change again. This part becomes 1 over 2. We reciprocate this to get 1 over 7 minus f of theta. And then we reciprocate the other one now. And so we're going to get 1 over 12. That's 1 over 12. Nice. All right. And so what can we conclude? We can conclude that the maximum is going to be a half and the minimum is 1 over 12. And so hence the maximum will be 1 over 2 and the minimum will be 1 upon 12. All right, nice and easy, soft. That's what we have. That's the max and that's the min. And that takes care of question 3. Very easy, soft. Now we can go to question 4. Question 4 says the circles C1 and C2 are defined by the parametric equation as follows. C1 is x equal to root 10 cos theta minus 3, y is root 10 sin theta plus 2, and C2 is another parametric equation, and from C1 and C2 it said determine the Cartesian equation of both of them. So let's do that. All right, so we have C1 is such that we have x is equal to root 10 cos theta minus 3, and we have y is equal to root 10 sin theta plus 2. So the first thing we're going to do is we're going to make cos theta and sin theta the subject. All right, you might wonder why. You'll see why soon. We add 3 to both sides. Add 3 to both sides. And then we divide by root 10. And so we have x plus 3 over root 10 is equal to cos theta. It's going to give us cos theta. All right, and over here now, we subtract 2 from both sides to get y minus 2 divided by the root of 10. And that is equal to sin theta. This is sin theta. Now that we get this now, all right, what do we do next? We square both sides. That's the next thing that we do. We square both sides. By squaring both sides, you are going to get that cos square theta, squaring both sides, you get cos square theta is equal to x plus 3 all square over root 10 square is 10. Alright, so that's cos square theta. Over here now, you're going to get that. When you square both sides, you're going to get that sine square theta over sine square theta is equal to y minus 2 all square over the root of 10 square is just 10. Alright, but then what do we know? We know from ADMATH days, this identity, we know that sine square theta plus cos square theta, sine square theta plus cos square theta is equal to 1. We know this identity from ADMATH. And so since sine square theta plus cos square theta equal 1, and we have an expression for cos square theta, and we have an expression for sine square theta, and what that means then is x plus 3 squared over 10, x plus 3 squared over 10 plus y minus 2 squared over 10, y minus 2 squared over 10, that's equal to 1. Alright, so we can multiply through by 10. And so the Cartesian equation of C1 is given by, when we multiply through by 10, we're going to get x plus 3 all square, x plus 3 all square, plus y minus 2 all square, and that's equal to 10. That's equal to 10. Alright, nice and easy. Soft. Now, since I said to write it in the form r squared, then you can rewrite this as root 10 all square. Instead of saying 10, write it as root 10 all square. Right? And that is for C1. We're going to do the same for C2. So let's do the same for C2. For C2, they give us 4 cos theta plus 3. They give us 4 cos theta plus 3 is equal to x. And so all we need to do is make cos theta the subject. Making cos theta the subject, we're going to get cos theta. Cos theta is equal to, we subtract 3 from both sides, so we get x minus 3, and then we divide through by 4. To get cos theta is x minus 3 over 4. And then over here now, this is x, and this is y over here. And it told us that y is 4 sine theta plus 2. So we have 4 sine theta plus 2. And this is equal to y. So we need to make sine theta the subject. To make sine theta the subject, we're going to get that the sine of theta is equal to y minus 2 divided by 4. That's going to be the sine of theta. So since this is the sine of theta, which is y minus 2 divided by 4, all right, this is sine theta and this is cos theta. Now we can go ahead. We have cos theta, we have sine theta. Now we can go ahead and use the identity that we know, that cos square theta plus sine square theta is equal to 1. Cos square theta plus sine square theta is equal to 1. Alright, since cos square theta plus sine square theta is equal to 1, this implies that cos theta is going to be x minus 3 over 4 all square plus sine squared theta is going to be y minus 2 over 4 all square, and that's equal to 1. So all we need to do now is multiply through by 4 square. When we multiply through by 4 square, we're going to get x minus 3 all square plus y minus 2 all square, and that's equal to 4 square. All right, and that takes care of part 1. All right, nice and easy, soft. Let's look at part 2. Part 2 says, hence, find the point of intersection between the two. Find the point of intersection. So let's go back and write down the two equations. This is one of them. One equation that we have is x minus 3 all square plus y minus 2 all square, and we have that that's equal to 4 square, that is really 16. All right, and another equation that we have is around here, it is x plus 3 plus x minus 2, x plus 3 square plus y minus 2 all square is 10. All right, let's write down the next equation over here. Next equation we have over here is x plus 3 square plus, what was that, y minus 2 plus y minus 2 all square plus y minus 2 square is equal to 10. So we need to solve these two equations. To solve them, the first thing I'm going to do is expand them. All right, we need to expand them first. So we need to get them from the standard form to the general form. The general form for the first one will be x squared minus 6x plus 9, x squared minus 6x plus 9 plus y squared minus 4y plus 4, and that's equal to 16. All right, that's the first equation in general form. This equation in general form will be x squared plus 6x plus 9 plus y squared minus 4y plus 4 is equal to 10. All right, that's equal to 10. So to find the points of intersection now, we're going to solve these two equations simultaneously. To solve them simultaneously, what we're going to do is let's subtract them. Let's subtract these two equations. So we're going to subtract them, and what we're going to get is x squared minus x squared gone, minus 6x minus 6x become minus 12x. Then we're going to have 9 minus 9, 9 minus 9 cancel, y squared minus y squared cancel, minus 4y minus minus 4y, minus and minus give us plus, so that's 4y minus 4y, that cancel. 4 minus 4, let's go again, 4 minus 4, that goes away too, and then 6 minus 10, 6 minus 10 is 6. So we get minus 12x is equal to 6. So we can divide through by minus 12 and say x equal negative a half. X equal negative a half. Now that we get x equal negative a half, we need to find out what's the y value. So we can plug in x being negative a half into any one of these two equations to find the y value. All right, so let's plug it in the first equation. So plugging it in the first equation, you can use either this equation or this, doesn't matter. Plugging it in the first equation, you're going to have minus a half minus 3, minus a half minus 3 square plus y minus 2 all square. That's equal to 16. All right. This is when we put x as minus half. So we put x as minus half into the first equation. Putting x as minus a half. All right. Putting x as minus a half, as we can see, the equation will simplify now to just be minus a half minus 3 all square, minus a half minus 3 all square. This part works out to be 12 and a quarter. So we get 12 and a quarter plus y minus 2 all square plus y minus 2 all square. We get that's equal to 16. So all we have to do now is subtract 12 and a quarter from both sides to get. That implies y minus 2 square, y minus 2 square is equal to 16 minus 12 and a quarter. So work out what is 16 minus 12 and a quarter. I get 3 and 3/4. And so then what you do is square root both sides. So you square root both sides to get now y minus 2 is equal to plus or minus. Remember, when you square root, you get two values. Square root of 3 and 3/4. I get 1 point. Let me see if I can leave it as a third. I'm not going to write 3 and 3/4. This is 12, 15 over 4. This is 15 over 4. And so it is plus or minus the square root of 15 over 4, which is known as the square root of 15 over 2. So it's plus or minus the square root of 15 over 2. So that implies that y is equal to, you're going to get two values for y. Y is either equal to 2 plus the root of 15 over 2, 2 plus the root of 15 over 2. Y is equal to 2 plus the root of 15 over 2, or y is equal to 2 minus the root of 15 over 2. All right, those are the points of intersection. So in conclusion, you can write them down now. Points of intersection are, can just give them it in a nice little way. Points of intersection are, we're going to give them the coordinates. You have when x is minus a half, you have minus a half, comma, you have 2 minus the root of 15 over 2. That's one point of intersection. Or the next point of intersection is minus a half, comma, 2 plus the root of 15 over 2. All right. Now this question may have seemed challenging, but I want you to get the picture in your head. All right. Now, based on the two equations that we have, we had two circles. This is a circle with center 3, 2. And this is a circle with center minus 3, 2. Radius of 4 and a radius of root 10. So I'm going to show you a schematic of what we had. So in reality, we have a circle. Let me draw a circle. So this is graphically. So I'm going to show you graphically what we have. This is graphically. It's always good to get a picture of what's going on. Graphically. Graphically, what we have is we have a circle. Let me make it smaller so I can fit both circles on the page. All right, so graphically, the first circle that we have, the center was 3, 2. This is a center of 3, 2. And it had a radius of 4. All right, that's what we had. Now look at this one now. This one is a circle with center minus 3, 2 and a radius of root 10. Minus 3. So minus 3 would be, if this is positive 3, minus 3 somewhere over here. So we have another circle somewhere over here. Looking something like this with a smaller radius. So another circle somewhere right there. Let me move it over a little. Let me move it over, please. Let me move it over. So it's like this is the circle that we have, and this right here is the circle minus 3, and the y value is still 2, and this radius is just the root of 10. This radius is the root of 10. All right, so this is the circle that we have. All right, these are the two circles. This is going to be C2 and this is C1. For persons that love to see axis, I can put on an axis just for you, right? So your x-axis would be, and x is 0, 0 would be somewhere right here. This is your x-axis, all right? This is your x-axis, all right? And your y-axis is somewhere right here. All right, this is your x and this is your y, and they intersect. Let me move over this circle a little bit better. This doesn't look quite right. All right, and these are the 2 points of intersection with the same x values. Let me put it in red. These are the 2 points of intersection, x being minus a half, x being right here, right? And that's that. This center of this circle is minus 3, 2. So something like this is how they look. Something like this is not accurate. All right, so one of them is when x is minus a half. Both of them have the same x value, but the y value is different. This is going to be the 2 plus root 15 over 2. This is the 2 plus minus root 15 over 2. All right, so this is just graphically what is happening. I really hope this makes it a lot more clear, nice and easy. Now let's look at part B. Part B is locus. Part B is locus. All right, part B says a point P of x moves so that its distance from the fixed point 0, 3 is 2 times the distance from a fixed point 5, 2. Show that the equation of the locus of the point P of x is a circle. So anytime I get a question like with locus, I just like to sketch what is going on. It's always good to see what is going on. So I like to put an x and a y-axis. I know it sounds crazy, but I like to see what's going on. You have the point 0, 3. X is 0, y is 3. I can call this point A. You can reference it if you want. The point A is the point 0, 3. And I have the point B. And I have the point B that is 5, 2. 5, 2 can be somewhere like 5. This is 2. This can be B, somewhere right here. B is the point 5, 2. All right. And it says you have some point P. You have some point P that is moving so that the distance from the fixed point 0, 3 is 2 times the distance from the point 5, 2. So the distance right here, the distance from P to A is 2 times the distance from here. So what they're saying is the distance PA is equal to 2 times PB. Now we don't know where P is. I'm going to put some possibility where P could be 2 times this distance, must be this distance. So let's say 2 of PB will make it equal to PA. So if A is, I want it to be twice it. Let me see. If P is here, like let's use this for example. Let's say P is here. This is just a rough estimate. Let's say P is here. Then this distance PB is a half this distance PA. That's a possibility. Now let's say P is here. P could be here. These are just possibilities. If P is here, then this distance here is a half this distance here. All right, that's all we know. Wherever P is, we know that the distance PA is 2 times the distance PB. All right, so now let's use, we know how to find the distance between two lines. Going back to C-sec maths, it's the square root of x1 minus x2 all square. So it's going to be, P is the point xy, all right? And so it is x minus 0, so it's really x minus 0 square plus y minus 3 square plus y minus 3 square, and that is equal to 2 times the distance from P to B. So it's 2 times the distance of P to B, and the distance of P to B is x minus 5 square, x minus 5 square, plus, that's going to be y minus 2 square. Now, what we can do now is, I'm going to continue it, but I'm just going to close off up here. All right. So I'm going to continue by squaring both sides. So continuing down here, all right, continuing down here, continue all the way down here. By continuing, I'm going to square both sides. By squaring both sides, I am getting that x squared plus y minus 3 all squared is equal to 2 squared, and 2 squared is 4. So it's equal to 4 times all of what's in here, which is 4 times x minus 5 squared plus y minus 2 all squared. Notice I put B at the wrong spot because I put it in the negative axis. B should have been above, somewhere up here. All right, so notice that I put it the wrong place. So the only thing I could do to make this a little better is move the x-axis. Maybe like this. Yeah, so that's not too bad. All right. So now we're going to have to expand out all of this. By expanding out all of this, and you might wonder, why are we expanding? We want to show that the locus is a circle. If the locus is a circle, then it will take the form x minus a squared plus y minus b squared is equal to r squared. All right, so that's what we're trying to show. So we're going to get x squared plus y squared minus 6y plus 9, and that is equal to 4 times. If we expand out this side over here, it's going to be x squared minus 10x, x squared minus 10x plus 5 squared is 25 plus y squared minus, let me see, plus y squared minus, that looks like 4y plus 4. That is what we have. All right, good. Now, just to clean this up a little bit more, what we're getting then is x squared plus y squared minus 6y plus 9, that is equal to 4 times x squared is 4x squared. Then 4 times minus 10x is minus 40x. Then we have 4 times 25 is 100. We get plus 100. Then we have 4 times y squared is plus 4y squared. And then we have 4 times minus y is minus 16y plus 4 times 4 is plus 16. All right, that's what we have. Now, what do we do next now? We can bring everything to one side. So I'm going to make the left-hand side be 0. So 0 is equal to subtracting x squared from both sides. I get 3x squared. Subtracting the y squares, I'm going to get plus 3y squared. Subtracting 6y, I'm going to get minus 16y plus 6y. So over here becomes minus 10y. Then I put back the minus 40x. All right. And then I have 9 over here, so I'm going to subtract 9 from both sides. But I have 100 plus a 16, which is 116. Then I subtract 9. So this becomes 107. Over here, that becomes plus 107. And that's equal to 0. So what do we do now? We can then divide this equation by 3. So let's do that around here. Dividing through the equation by 3, we're going to divide through by 3. So what we're going to get is, let's put the 0 on the opposite side now. All right, dividing through by 3, we're going to get x cubed, not x cubed, x squared, my apologies, plus y squared. Then dividing 40x by 3, we get minus 40x over 3. Or some people might write it as minus 40 over 3 times x. Then we're going to divide the y now by 3, so we're going to get minus 10. We're going to get minus 10 over 3 times y. And then we're going to get the number now. 107 divided by 3, so we have plus 107 divided by 3, and that is equal to 0. So now when we have this now, all we need to do now is put this in standard form to see if it's a circle. I cannot tell if this is a circle yet, so I need to put it in standard form. To put in standard form, I'm going to complete the square for the x terms. So I'm completing the square for this and this. So it's going to be completing the square. I'm going to have x minus half of this is 40 over 6. This is 40 over 6 square and then I subtract 40 over 6 square plus, completing the square for these two terms now, I'm going to have y minus 10 over 6, y minus 10 over 6 square, and then I subtract back 10 over 6 square, and that's equal to, or put back the plus 107 over 3, and that's equal to 0. Now I'm going to put it in the standard form of a circle, so it's x minus 40 over 6 is really 20 over 3, so x minus 20 over 3 square plus, put this part now, which is now y minus 10 over 6 is really, divide both by 2, 10 over, that's 5 over 3, it's y minus 5 over 3 square. Then I have this minus 40 over 6 square. This part works out to be, this part right here works out to be minus 44 and 4 over 9. This works out to be minus 44 and 4 over 9. Then this part right here works out to be, this looks like minus 100 over 36. All right, and then plus 107 over 3. So all I need to do now is add up these three terms, and we're good. We'll add up these three terms and we're Gucci, we're nice. So let's add up these three terms and see what we get. So finally, what we get now is x minus 20 over 3, x minus 20 over 3 square, x minus 20 over 3 square, plus y minus 5 over 3 square, and adding up all of these, and I'm going to put equal to, so we're going to bring the sum over to here. So we have minus 44 and 4 over 9 minus 100 over 36 plus 107 over 3. All right, and we'll bring it over here. We're getting 11 and 5 over 9. So over here we're getting 11 and 5 over 9. All right, and so hence this is clearly a circle. So hence we can write it, hence the locus is a circle. Hence the locus is clearly a circle, and it is a circle with center. It is a locus is a circle with center 20 over 3, comma 5 over 3, and a radius of the square root of 11 and 5 over 9, and a radius of the square root of 11 and 5 over 9. Whatever that is, that's the radius. All right, hence the locus is a circle. Nice and easy, soft. And this takes care of question 2, and so this takes care of module 2. Nice and easy. Let's go to module 3. All right, so you sip some water. And you go to module 3. So go to module 3, question 5. Question 5 says, let f be a function defined as f of x is sine ax over x. Right, so f of x is equal to sine ax f of x is sine ax. Sine ax over x, and f of x is also 4. F of x is sine ax over x. This is when x is not equal to 0, of course, and it's equal to 4 otherwise. And this is if x is equal to 0. And they said now, find the value of a if the function is continuous. If the function is continuous, all right, so what we can write is, since f is continuous, then since f is continuous, then we know that f of 0 is equal to 4. Yep, f of 0 is equal to 4. All right, and the left-hand limit is equal to the right-hand limit. All right, the part that we're really going to utilize is the fact that the left-hand limit is equal to the right-hand limit. So what does that mean? That means we're going to utilize the fact that the limit as x approaches 0 of sine ax over x, this limit is equal to the limit as x approaches 0. It's equal to the limit as x approaches 0 of 4. Now, the limit as x approaches 0 of 4 is just 4. All right. Now, look what we're going to do now. Over here now, this side, we have the limit of sine ax over x. Now, we know that the limit of sine x over x as x approaches 0 is 1. So what we're gonna do is multiply. We're gonna put an a down here. But if we put an a down here, we have to put an a up here. All right, we have to put an a down here. Now put an a here. We're multiplying by a over a. That makes sense? Yes. Then look how we're gonna write this now. Now we're gonna write this as the limit as x approaches 0 of a times, in bracket, sine ax over ax. Sine ax over ax. Now the limit as x approaches 0 of sine ax over ax is 1. All right. Now, according to limit laws, the limit of a product is equal to the product of the limits. So we can rewrite this as the limit as x approaches 0 of a multiplied by the limit as x approaches 0 multiplied by the limit as x approaches 0 of sine ax over ax. Nice and easy, soft. So this is what we have. The limit as x approaches 0 of sine ax over ax. This is equal to 4. Now the limit of sine ax over ax, this part is 1. And the limit as x approaches 0 of a is a. So what we're getting is a times 1 is equal to 4. And since a times 1 is equal to 4, this implies that a equals 4. All right, nice and easy. So a equals 4. Soft. No issues. The next part of the question, it says that using first principles, determine the derivative of f of x, which is equal to sine 2x. Determine the derivative of f of x, which is sine 2x. All right, so f of x is equal to sine 2x. All right, now to find the derivative from first principle, we have to remember that f prime of x, using first principle, f prime of x is equal to the limit, it's equal to the limit as h tends to 0 of f of x plus h is equal to f of x plus h minus f of x over h. That's how we find the first derivative. All right, so let's plug in this now. So it's going to be equal to the limit as h tends to 0. It's the limit as h tends to 0 of, we can go ahead and put sine. So it's the limit now, f of x plus h is going to be the sine of, you're replacing x with h, so it's going to be 2x plus 2h, or you can write it as the sine of 2 times x plus h, 2 times the sine of x plus h, minus the sine of 2x over h. Right? So that's what we're going to do. So let's break that up now. That is equal to now the limit as h tends to 0 of, now there are two ways I can do this. Now this sine of 2x plus h, all right, I am going to rewrite this right here as sine 2x plus 2h. This is really the sine of 2x plus 2h when you're expanding the 2. Now using the compound angle for that, we know that the compound angle is sine 2x cos 2h, sine 2x cos 2h plus cos 2x sine 2h plus cos 2x sine 2h sine 2h minus sine 2x, and this is all over h. Everything is all over h. So what do you do next? Now one thing I notice is that this right here, we have sine 2x right here, and we have sine 2x right here. So we can group those two, and we can factorize sine 2x from those two. So this is going to be equal to the limit as h approaches 0 of, I'm going to group these two and factorize out sine 2x. If I factorize sine 2x, I am left back with, in the bracket, that's going to be cos 2h. And then when I factor out sine 2x from this right here, I get minus 1. All right. And instead of writing everything over h, I'm going to divide this side specifically by h and write plus the limit as h approaches 0 plus the limit as h approaches 0 of cosine 2x sine 2h over h. All right. Nice. Now using laws of limits, the limit of their product is the product of their limit. And so what I'm going to do is right here, so I have a cos 2h here, and so I need a 2h in the denominator. So I'm going to put a 2 right here and put a 2 up here. All right. I need a 2 in the denominator, so I'm going to put a 2 right here and a 2 up here just to make it balanced. Then using limit laws, all of this work out to be equal to, it's going to be the limit as h approaches 0 of, it can be written now as limit as h approaches 0 of 2 sine 2x, limit as h approaches 0 of 2 sine 2x multiplied by Limit of the product is the product of their limits multiplied by the limit as each approaches 0 of. I separated them now as two different products, and so now this is just cos 2h minus 1 over 8 over 2h. But remember, the limit of cos theta minus 1 over theta is 0, right? Plus the limit as h tends to 0, separating them as the limit of the product now. That is now 2 cos 2x plus the limit of 2 cos 2x over 1 times the limit as h tends to 0 of sine 2h over 2h. This is now sine 2h over 2h. Sine 2h over 2h. All right, that's what we have. Now that this is what we have, this is now equal to, plugging in h as 0, now the limit as h approaches 0 of this is just 2 sine 2x. This is just 2 sine 2x. But then plugging in h as 0 here, you get times 0. That becomes times 0 plus, when you plug in now h as 0 here, you're going to get 2 cos 2x. 2 cos 2x times the limit as h approaches 0 of sine 2h over 2h is 1. And so the final answer is anything times 0 is 0. So the final answer is 2 cos 2x. So the final answer is 2 cos 2x. Nice. So we can put it up here. That is f prime of x is equal to 2 cos 2x. Nice and easy, soft. This question, soft, a capital T. Now let's move on to part C. Alright, so part C, as it is saying, it says that y is equal to 2x over the square root of 1 plus x squared. Now this question, I am going to use implicit differentiation to do this. Anytime I see square root, implicit come to my mind. Anytime I see square root, honestly. If you don't know implicit differentiation, click the link in the description and watch that video on implicit differentiation. So to do implicit differentiation, first thing we're going to do is square both sides. So we're going to get y squared is equal to, y squared is equal to, when I square both sides, I'm getting the numerator, when I square it, is 4x squared over the denominator is 1 plus x squared. Now doing implicit differentiation is easy for me to differentiate this now. Doing implicit, I can differentiate this now to carry down the power to get 2y times dy by dx. That's implicit differentiation. So that becomes 2y dy by dx is equal to, start with the bottom, which is 1 plus x squared, times the differential of the top. The differential of the top is, that looks like 8x minus the top, which is minus 4x squared, times the differential of the bottom. The differential of the bottom is 2x over the bottom square, and the bottom square is 1 plus x squared. Nice, this is 1 plus x squared. Okay, 1 plus x squared all square. Now I'm going to expand out the numerator Expanding out the numerator, I get 1 times 8x is 8x plus 8x times x squared is 8x cubed. And then I have 4x squared times 2x, that's also 8x cubed. So notice that the 8x cubed, them cancel each other. All right, and now I'm just dividing by 1 plus x squared all square. So the differentiation part done already. All we're doing is just testing our algebraic skills now. Differentiating part done is just algebraic skills. So this implies now we have 2y dy by dx, 2y dy by dx. We have 2 dy by dx is equal to, we have that this is equal to 8x plus 8x cubed minus 8x cubed. So that is just 8x over 1 plus x squared all square. 1 plus x squared all square. All right, nice. Now, next thing we're going to do is divide through by 2. Dividing through by the 2y, we're going to get dy by dx. So we're going to get dy by dx is equal to, when we divide through by 2, this becomes 4x over, we divide through by 2y now, you know. So this becomes 1 plus x squared square, 1 plus x squared all square times y. All right. But remember the question wanted x dy by dx, don't it? It wants x dy by dx. So to get x dy by dx, we need to multiply both sides by x. So let's multiply both sides by x. So what that is giving us then is x dy by dx is going to be equal to, multiplying both sides by x, we're getting 4x squared over 1 plus x squared, 4x squared over 1 plus x squared all square times y. But now look at this now. Look at this. Remember 4x squared, I can break up 4x squared as, 4x squared can be broken up as 2x times 2x, don't times 2x squared, don't it? I can break up the numerator as 2x times 2x. Then in the denominator, I can break up 1 plus x squared as the square root. I can break up 1 plus x squared as the square root of 1 plus x. This can be written as the square root of 1 plus x times the square root of 1 plus x times 1 plus x squared. This is the square root of 1 plus x times the square root of 1 plus x times 1 plus x squared. And it is still being multiplied by y. I can break up the denominator like that. All right, nice. Okay, good. Now look at this now. What is 2x over, what is 2x over the square root of 1 plus x? But look at this, we don't even have to write the numerator as 2x squared. We don't even have to write it like that. We can write the numerator as 2x times 2x times x. Yeah, man, times x. Because guess what? Guess what? Look at that now, 2x. As we can see, this part right here, wait, 4x squared. Yeah, 4x squared is 2x times x. My apologies. 4x squared is 2x times 2x. Now, what am I saying now? I am saying that this 2x over the square root of 1 plus x, this part is y. This is y, and this 2x, that is y, and this 2x over the square root of 1 plus x is also y. This part is also y. Nice. And so what we're getting is that this answer is working out to be y times y is y squared. So I'm getting y squared over 1 plus x squared times y. 1 plus x squared times y. So that is x dy by dx. So to finish it off, we have that x dy by dx, x dy by dx, x dy by dx is equal to, we have y squared over 1 plus x squared times y. We can then divide. We can see that the y square, this y square, you can break up y square as y times y in the numerator. And if you break it up as y times y, this y cancels this y. And so finally we can conclude that x dy by dx, x dy by dx is equal to y over 1 plus x squared. So again, just use implicit differentiation and it works out so easy. I highly recommend learning implicit differentiation. I know a lot of teachers do not teach implicit differentiation at the Unit 1 level. So I highly recommend you learn it, and you should. If you don't know implicit, check out the link in the description to watch implicit differentiation. Now let's look at part 2. Part 2 of the question, it says, show that d2y by dx squared plus 3y over 1 plus x squared all squared is equal to 0. So to show part 2, right? Oh, make sure you put that you show it now. So proven, all right? So it's proven, all right? Okay, so for part 2, it's a second derivative question. What I ideally, anytime I prove something, I like to start with that. So I just proved that x dy by dx, x dy by dx is equal to y over 1 plus x squared. All right? X dy by dx is y over 1 plus x squared. So I'm going to start with that. X dy by dx is y over 1 plus x squared. So if I divide both sides by x, if I were to divide both sides by x, in reality, dy by dx is really equal to y over 1 plus x. Y dy by dx is y over 1 plus x squared times x. All right, that's dy by dx. So now from this, I can go ahead and find the second derivative. The second derivative, I'm going to use quotient rule. So d2y by dx squared is equal to, start with the bottom. So the bottom is 1 plus x squared times x. In reality, that is x plus x cubed. So it starts with the bottom times the differential of the top. When you differentiate y, you get dy by dx. And we already know what dy by dx is. It's in this line, minus the top, which is y, times the differential of the bottom. When you differentiate the bottom, you are differentiating x plus x cubed. When you differentiate x, you get 1. When you differentiate x cubed, you get 3x squared. And this is all over the bottom square. I don't like this line. Let me fix it better. All over the bottom square. When I'm squaring 1 plus x squared, what I'm going to get is 1 plus x squared square. So I get 1 plus x squared square times x squared. That's what I get when I square the denominator. So this is d2y by dx squared. So going around here, what I get is d2y by dx squared, d2y by dx squared is equal to, now that I have this, x plus x cubed dy by dx minus y times 1 plus 3x squared over this. I can go ahead now and simplify this. Let's go ahead and simplify this. I notice that this part, I can separate them as two separate fractions. Yes, I'm going to separate it as two separate fractions. I'm going to write it as x plus x cubed dy by dx. And instead of writing x plus x cubed, I'm going to write it as x into 1 plus x squared times dy by dx. And this is all being divided by all of this is being divided by 1 plus x squared over x squared. I don't need to separate them yet. Let's just continue writing it out. So x times 1 plus x squared minus, I'm going to expand in with the y now. Expanding the y, it's going to be minus y minus 3x squared y. So it's minus y minus 3x squared y minus 3x squared y over, this is over 1 plus x squared, 1 plus x squared, all square times x squared. All right, now let's look at how we can simplify this now. We want to simplify this, and as I can see, remember we said that what is dy by dx? What is dy by dx? We're going to substitute for dy by dx right now, and everything else will work out. Remember we just said that dy by dx, going around here, this is dy by dx, y over 1 plus x squared times x. So I'm going to plug in that in here for dy by dx. So I'm going to make a big substitution, so pay close attention. So it's x times 1 plus x squared, and we had said that dy by dx is equal to, again, let's go back, look at it. It's y over 1 plus x squared times x. So dy by dx is y over 1 plus x squared, 1 plus x squared times x. That's dy by dx minus y minus 3x squared y over 1 plus x squared times x squared over 1 plus x squared all square times x squared. Right? Now what you get now is this 1 plus x squared cancels the 1 plus x squared. This x cancels the x here. Ah, nice. So all of this is just working out now to just be, this in the numerator works out to just be y minus y that gone. So it's just working out to be y minus y minus 3x squared y minus 3x squared y over 1 plus x squared all square times x squared. Right now it just gets so basic, it's so boring now. All right, so now it gets so basic that all we're getting now is d2y by dx squared. It's just equal to d2y by dx squared is equal to y minus y cancel, so you get minus 3x squared y minus 3x squared y over 1 plus x squared, 1 plus x squared all square times x squared. Now, as you realize now, this x squared cancels this x squared in the numerator. And so what are we left back with? What we're left back with is minus 3y over 1 plus x squared all squared. So now that this is what we get, we can just bring it over to the other side to get this implies now. Adding this to the other side, we're going to get d2y by dx squared plus 3y over 1 plus x squared all square. This is equal to 0. This is shown. Nice and easy, soft. This is shown. Nice. All right, so that is shown. Nice and easy, soft. All right, so this takes care of question 5. And now we reach the penultimate question of the paper. Penultimate means second to last. But we reach the final question of the paper, which is question 6. All right. Now question 6 says the diagram below shows a region bounded by the lines y equals 3 minus x, y plus x equal 9, and 3y is equal to x plus 3. Now before I even do this question, I noticed that I have equations of lines, and I just like when all of them in standard form. That's me. It really annoys me when they're not in standard form, and I'm going to perform simultaneous equations. So y is 3x minus 7. The other one, if I make y the subject, the one that says x plus y is 9. From that one, it is telling me then that y is equal to, that looks like 9 minus x. And the final one that tells us that 3y is equal to x plus 3. I'm going to rewrite it as y is equal to 1 over 3 times x. So it's 1 over 3 times x. All I do is dividing through by 3 plus 1. So I put all of them in standard form. Makes it easier. It makes it easier. 1 over 3 times x plus 1. It makes it easier for us to can do other computations with these lines. Now let's hear what they say. They say show that the coordinates of A, B, and C are 4, 5, 3, 2, and 6, 3 respectively. So I'm going to draw a schematic of the curves. We have this. I'm going to draw the lines in red. So you have the line 3x minus 7. That's a gradient of positive 3. Gradient of positive 3 and cuts the y-axis at minus 7. So this can be something that resembles that. All right, so that's the line that we have. This is minus 7. All right, with a gradient of positive 3. Then we have the line y equal 9 minus x. Let's put that in another color. 9 minus x pass through positive 9 with a gradient of negative 1. That looks something like this. All right. Gradient of negative 1. So that looks something like this. Let me put that this is the point positive 9. So let me label them as L1, L2, L3. This is L1, this is L2, and then I need L3. L3 is going to be L3, as you can see, L3 is 1/3 x plus 1. So it cuts the y-axis at positive 1. Cuts the y-axis at positive 1. So L3 looks something like, and it has a gradient of 1 over 3 All right, so it cuts the y-axis at +1. All right, so this can represent, no, let me make it a little better. This can represent L3, all right? This can represent L3, and this is y-axis intercept +1. All right, I just like to put it on a graph. It makes it easy for me to see what's going on. So this is L3, all right? So now the 3 points of intersection are here, here, and here, all right? And they want us to show that the coordinates A, B, and C are those respectively. So to do that, the first thing we can realize is that A is the intersection between L1 and L2. So write that down. So A is the intersection of L1 and L2. All right, so we're going to solve those two lines simultaneously to find the coordinates of A. So solving them simultaneously, as we can see, A being the intersection of L1 and L2, we have y is 3x. So we have y is equal to L1 is 3x minus 7. And then the next one is x plus y. So it's going to be x plus, what is y? Y is 9 minus, y is 3x minus 7. All right, we substitute it into the second one, that's equal to 9. All right, and so what that implies then is that we're getting 4x minus 7 is equal to 9. And so that is telling us that 4x is equal to 16. And so that is then telling us that so x equals 4. If x is equal to 4, we plug it in y, and so y is going to be equal to 3 times 4 minus 7. So 3 times 4 minus 7, that will give us y. And what is 3 times 4 minus 7? When you work that out, what we're getting is 3 times 4 minus 7. 3 times 4 minus 7, that works out to be 3 times 4 minus 7 is 5. Is that the point A? A is 4, 5. Let's check it. Yes, we get it. And so A is the point 4, 5. A is the point 4, 5. Now that we get the point A, next thing we need now is to find the point B. Now B is the intersection of L1 and L3. So B is the intersection of L1 and L3. That is B. B is the intersection of L1 and L3. So now what is L1? L1 is the equation y is equal to 3x minus 7. That is L1. All right. And L3 is the equation 3y. L1 and L3. L3 is 3y plus 3y is equal to x plus 3. And then remember, y is 3x minus 7. So substitute it here, 3x minus 7. Solving this equation, what we're going to get is 3 times 3x is 9x minus 3 times 7, that's 21. That's equal to x plus 3. Bringing x over there, so we're getting 8x is equal to 21 plus 3 is 24. Dividing both sides by 8, and so x is equal to 3. Since x is equal to 3, y is going to be equal to 3 times 3 minus 5. And so y works out to be 9 minus 5 is 4. Is that right? All right, so did we make any mistake? Because 3 times 3 is 9, 9 minus 5 is 4, but it shouldn't be 4. Let's look. Oh, my apologies, it should be 7. And so that becomes 2. And so now we get B is the point. So B is the point. B is the point that is, what we got for X again? 3 and 2. Finally, we have now C. C is the intersection. C is the intersection of, C is the intersection of, that looks like L3. C is the intersection of L3 and L2. All right, and what we had for L2, L2 was X plus Y, or we had write it as Y is equal to 9 minus X. And then L3 was 3Y, and so it's going to be 3 times Y, which is 9 minus X. That's equal to X plus 3. So we can go ahead and solve this now. And we're going to get 27 minus 3X is equal to X plus 3. And so we're going to get that. So we're getting that. Bring over the 3X over here, we get 4X. Bring over the 3X over here, we get 4X. Bring over the 3 over here, we get 27 minus 3. 27 minus 3 is 24. And so X is equal to 6. If X is equal to 6, Y is going to be equal to, X is 6. 9 minus 6 is 3. And so C is the point. X is 6, Y is 3. And so all of those are shown. Nice and easy, soft. Shown. All right, nice. So now we've shown all of this, all right? All of these are shown. Now we need to go ahead now and we need to find, use integration, determine the area bounded by the curve. Well, I wouldn't want to say curve, the area bounded by the lines. Now the area bounded by the lines is a triangle here. So it's the area of the triangle we're ultimately finding. So the area of the triangle we're finding is in here. All right. So the area in here. So the area in here is going to be, remember, we'll find area, it's going to be the integral of this line from this point to this point plus the area of this line from this point to this point minus the area below this line. Ah, I see it. Nice. So we're going to integrate from this point to this point of this line. So let me write it down here. We're going to call it area A. So this is part 2. So the area A is going to equal to the integral of this line. This line is L1. So we're integrating L1 from B to A. So we're integrating from B was the point, I think that was X point was 3. So integrating from 3 to 4. Integrating from 3 to 4 of L1 plus we're then going to integrate. We're going to integrate then from A to C. From A to C is 4, 6. And which line are we integrating from 4 to 6? We're integrating L2 minus, then now we need to subtract the integral of this line now, which is minus the integral of L3, and we're minusing the integral of L3 from B to C. From B to C, which is from 3 to 6. All right, so we're subtracting that integral. All right, minus the integral from 3 to 6 of BC, and that BC line was L3. So let's work this out now. So the area is equal to the integral from 0 to 4 of L1. Remember we had found L1. L1 was 3x minus 7. So we're integrating 3x minus 7. That's why it's good to have the graph. It makes it a lot easier. So it's 3x minus 7 dx plus the integral from 4 to 6 of L2, and L2, we put it as 9 minus x, that's y, 9 minus x, minus the integral of L3, which is from 3 to 6 of 1 over 3x plus 1, 1 over 3x plus 1. I left off my dx, but don't kill me. So now we're going to integrate them, and so the area that we're getting is equal to 3x integrated minus 7. I'm going to get 3x squared over 2. So I'm going to get 3x squared over 2 minus 7x. And remember, when we integrate, we're integrating from, that was from 3 to 4, plus we're then integrating L2. When we integrated L2, we're going to get 9x minus x squared over 2. That's plus 9x minus x squared over 2. And we're integrating from 4 to 6. Integrating from 4 to 6. And then what we're getting is minus the integral from 3 to 6 minus the integral from 3 to 6 of 1 over 3x plus 1. So integrating 1 over 3x plus 1, integrate that, we're going to get 1 over 3x squared, and divide that by 2, it becomes 1 over 6. All right, 1 over 6. Just making sure, again, integrating 1 over 3x, it becomes x squared divided by 2x squared over 6. This becomes x squared over 6. And then plus 1, you integrate plus 1, you get x. And we're integrating from 3 to 6. So now you just time to use up your calculators, and that will give you the area. So the area of the triangle, when I put in 4 in my calculator, I'm going to work it out. 3 times 4 squared divided by 2 minus 7 times 4. When I put in 4, I'm getting negative 4. Then I put in 3 now minus. When I put in 3, I get 3 times 3 squared divided by 2 minus 7 times 3. I get minus 7.5, so I get minus 7.5 plus, now I need to put in this now, which is 6 and 4. When I put in 6, I get 9 times 6 minus 6 squared divided by 2. I get 36 to be the answer. Then I put in 4. I'm going to get 9 times 4 minus 4 squared is 16 divided by 2. I get minus 28. 36 minus 28. Minus, I put in 6 now. Put in 6 squared. 6 squared is 36 over 6, which is 6 plus 6, which is 12. And I put in 3. 3 squared is 9. And I get 9 over 6 is 1.5 plus 3, which is 9.5. So I subtract 9.5. Okay, almost finished. So now I put all of this in my calculator. Minus 4 minus 7.5. This part is 3.5. Plus this part is 36 minus 28, that's 8. I'm positive. Minus 12 minus 9.5. 12 minus 9.5 is 2.5. We're getting is 3.5 plus 8 minus 2.5. I'm getting 9. All right. Now, anytime you get an answer, you just want to check to make sure you are integrating properly. 9 minus 3x squared over 2 minus 7x. 9x over x squared over 2. X squared over 6 plus x. So all of these are integrated properly. Just want to check again. 4 here is 12. 12 times 3, 36. 36 over 2, 18. 4 here is 28. 3 times 4 squared divided by 2 minus 7 times 4. That's minus 4. This is fine. Just checking back over one final check, because sometimes we make calculation error. 3 times 3 squared divided by 2 minus 7 times 3 minus 7.5. So this is good. Over here now, 9 times 6. 54 minus 6 squared. 6 squared is 36. 36 over 2. That's 36. Put in 4. 9 times 4. 9 times 4 is 9 times 4 is 36. Put in 4 in here. 4 squared. 4 squared is 16. 16 over 2 is 8. So 28 is fine. Minus. Put in 6. 6 squared. Divide by 6 is 6. Plus 6 is 12. 3 squared. Divide by 6. Plus 3. Okay, I see the mistake now. This shouldn't have been 9.5. This should have been 4.5. See how easy we made a mistake? That's 4.5. So when I subtract these two, it's 12 minus 4.5. 12 minus 4.5 is 12 minus 4.5 is 7.5. So the answer is 4. And you might have wondered why I was checking so rigidly for this answer. That's because looking at the triangle area don't look like it was so much. How do I know? I'm going to test it. I really wanted to show you all this method. All right. I don't know if you all remember from CSEC. From CSEC, there's formula. There's always a formula sheet for area, right? So remember, we're trying to find this area in here, the area shaded, which is the area of this triangle, right? There's a formula that's always been on the CSEC paper that a lot of people, they never even utilize ever. There's a formula that tells you that area A is equal to the square root of S times S minus A times S plus A, S minus A times S plus A, S minus A times S minus B times S minus C. This formula is on the CSEC paper and we never ever utilize it. So I'm going to utilize it now to show you that the area of the triangle is indeed 4. All right, always remember this formula. Well, you don't have to, but I like you to. So A is the length of AB. So this is A. BC is the length B, and this is C. So we need to find these three lengths, A, B, and C. So finding these three lengths, That means we need to find the length AB. The length AB would be equal to, remember it's x1 minus x2 squared. We already know B and we know A. Remember A is the 0.45 and B is the 0.32. So if you were to find the length of the line AB, it's going to be the square root of x1 minus x2 squared. So it's 4 minus 3 is 1 plus 5 minus 2 squared is 3 squared, which is 9. And so AB is the length, the square root of 10. All right, so that's AB. Let's find the length AC. The length AC will be equal to, the length AC is equal to, C is the 0.63, so it's equal to 6 minus 4 is 2, so 2 squared is 4, that's the square root of 4, plus 5 minus 3 is 2, 2 squared is 4, and so AC is the square root of 8. And then we need to find the length from B to C, which is 6 minus 3 is 3, so 3 squared is 9, 3 minus 2 is 1, 1 squared is 1, so the length BC is also the square root of 10. And you might wonder, so sir, where are you going with this? Now look where I'm going with this. Going to C-set maths, all right? Now when you remember S is equal to A plus B plus C divided by 2. I know some of you would probably never use this formula. And so in this case, S is equal to root 10 plus root 10, which is 2 root 10 plus root 8 plus root 8 over 2. That is S. Now root 8 is 2 root 2, and so we can rewrite this as S is equal to 2 root 10 plus 2 root 2, because root 8 is 2 root 2 over 2. And when you do the division, you're going to get that S is just root 10 plus root 2. That is S, root 10 plus root 2. So you might say, sir, why is this important? Look why it is important. It's good when you can do your questions in multiple ways. So the area is going to be the square root of S. S, which we just see, is root 10 times root 2. Root 10 plus root 2. Root 10 plus root 2 times S minus A. S minus A is going to be root 10 plus root 2 minus root 10. Remember, A was root 10. A is what we call AB. The distance AB, we call that A. So it's root 10 plus root 2 minus root 10. So it just leave you back with root 2 for S minus A. S minus B also just leave you with root 2 because B was root 10. And then S minus C, we'll call C this distance, which was root A, root 8. And so this works out to be just root 10 plus root 2 minus root 8. Root 10 plus root 2 minus root 8. Now I want you to put all of this in a calculator. Put all of this in a calculator. You're going to get this is equal to the square root of, putting in all of this in a calculator, root 10 plus root 2. All right, that's 4.576 times root 2 times root 2 times root 10 plus root 2 minus root 8. That's equal to 16. And the square root of 16 is equal to 4. So look at that. The area here is 4. And when we use algebra from C-set maths, the area is 4. Now you didn't have to check it like that. You could have find one of these angles and use area is a half AB sine theta. And once you get the same answer, you know you're right. So the only reason why I did it this method was to check to show you that the integration method is the same. They're both the same. And so therefore we can conclude that the area is indeed correct. So it's good if you remember this formula. If you do mathematics later on in university, sometimes it's good when you know this formula, when you're going to be doing like vector calculus and stuff like that. All right. Nice. So now we move on to the next part of the question, which is part B. Part B, it says that we have the gradient of a curve at the point 0, 6 is given by 3x squared plus 8x minus 3. Gradient of the curve, so what they're telling you is dy by dx is equal to 3x squared plus 8x minus 3. That's dy by dx. And they want us to find the equation of the curve. The equation of the curve we're going to have to integrate. So y is equal to the integral of 3x squared plus 8x minus 3. When you integrate this now, when you integrate it, you're going to get y is equal to 3x squared. Add 1 to the power, you get 3x cubed over 3 divided by the power plus add 1 to the power, so you get 8x squared divided by 2 minus 3x plus some constant c. All right, nice. Now after you get a constant c, you're not quite finished just yet. You need to find this constant, but they tell us there's a point on the curve that is 0 minus 6. So they're telling you when x is 0, y is negative 6. Y is equal to negative 6. So when x is 0, y is negative 6. So we can put that in here, that negative 6 is equal to 0 plus 0 plus 0. And so c is negative 6. We don't even need to do nothing more. So the equation of the curve is given by y is equal to 3x cubed over 3 is x cubed plus 8x squared over 2 is 4x squared minus 3x plus c. All right, and that's the equation of the curve. Y is equal to x cubed plus 4x squared minus 3x plus c. So that's part 1. That's the equation of the curve. Nice and easy, soft, a capital T. Nice. Part 2. Part 2 is, we have now, it says find the coordinates and the nature of the stationary point of the curve in BI above. So we need to find the stationary point. So to find the stationary points, we solve dy by dx equals 0. So you can write that down. At stationary point, at start point, dy by dx is equal to 0. And so all we need to do is set dy by dx equal to 0. Set 3x squared plus 8x minus 3. We'll set that equal to 0. We'll set that equal to 0. We're going to just factorize it. So factorizing it, as we can see, we're going to get 3x and x. Looks like 3 and 1. 3 and 1. Signs are different. The greater product is positive. So this is plus, and this is minus. And so the two stationary points are occurring when x is equal to 1 over 3 or when x is equal to negative 3. Now, that doesn't give you the stationary coordinate or the point. You just have the x ordinate. To get the stationary points now, you need to plug in 1 over 3 in here to get what is y. So plug 1 over 3 into the equation of y right here. Plugging in 1 over 3 in here. So plugging in 1 over 3, we're going to get 1 over 3 cubed plus 4 times 1 over 3 square minus 3 times 1 over 3. And remember, c is minus 6, so you can change this, not plus c, put minus 6. Minus 6. And I'm getting, let me see, 27 times 6 plus 14. Let me put that in again. So x cubed 1 over 3 cubed plus 4 times 1 over 3 square minus 3 times 1 over 3 minus 6. I'm getting minus 6 and 14 over 27. So you're getting minus 6 and 14 over 27. That's what I'm getting for y. All right. Now, from here now, we're going to get y is equal to, plugging in minus 3, you're going to get minus 3 cubed plus 4 times minus 3 square minus 3 times minus 3 minus 6, which is 12. So you're getting, this is the point, 12. This is 12. Let me see. This is 12. So the two stationary points are, that looks like 1 over 3. I like to write them in order in terms of the negative coordinate first. So I'm going to write minus 3 over 12, minus 3 over 12, comma, and 1 over 3, minus 6, and 14 over 27. Now we need to determine the nature of each stationary point. So to determine the nature of each stationary point, what we are going to do now is, to determine the nature of each stationary point, what we're going to do is, we're going to find the second derivative. So the second derivative is d2y by dx squared. So d2y by dx squared is going to be equal to, when you differentiate this, you're getting 6x plus 8. That's d2y by dx squared, 6x plus 8. All right. And now you need a second derivative when x is minus 3. So when x is minus 3, when x is equal to minus 3, we're going to get that the second derivative, y double prime, is equal to, plugging in minus 3 here, and you get 6 times minus 3 plus 8. That's negative 10. That's negative 10. Now when x is equal, since it's negative 10, this is less than 0. And so when x is minus 3, that's a maximum point. This is a max point. All right. And then when x is equal to 1 over 3, when you plug 1 over 3 in here, you're going to get that y double prime, which is the second derivative, is equal to positive 10, which is greater than 0. So what does that mean? That is telling us then that this minus 312 is a maximum point. This is a maximum point. And this is the, over here, 1 over 3, this is the minimum point. Minimum point. Generally, the easy way to can tell which one is max and which one is min, which one are going to have the positive y value will be max, and which have the negative y value or the lower y value will be min. So that's that. So we're done. Finally, it says sketch the curve and clearly labeling the stationary points. So I'm going to sketch the curve now. Sketching the curve. This is the curve now. I'm going to sketch it. That's the curve. I know it doesn't look that well, but Let's work with it. This is how the curve look. We have our maximum point and our minimum point. All right, the maximum point, again, this was minus 312. Let me not make them so close. Let me try to sketch it a little better. Make it a little better. So maximum, then the minimum point. I think this looks better. All right, and the maximum point, this is the point minus 312, minus 312, and this is the point. This is the point, what is this point? 1/3 and -6 and 4/27. And then now, once you sketch those points, you can always put in your axis afterwards. So let's put in the axis afterwards. The axis, the x-axis is in between -3 and 1/3. So x-axis is somewhere, this is x being 1/3, x being -3. X-axis is between here, let me see. Can think of it as closer to 1/3. This is the x-axis somewhere here. And then my y-axis, if this is positive 12, and this is -6 and 4/27, it's closer to down here. So this is my y-axis. You want to make it good. Yeah, that's my x. This is my y-axis. This looks not too bad. This don't look too bad. All right. My x-axis, my y-axis. This don't look bad at all. X is 1/3, y. So this is a point where y is -6. This is a y-axis intercept. Now we don't know the roots. We really don't know these roots. These are the roots. All right, this is your y-axis. This is your x-axis. And that's it. That concludes this paper. Nice and easy. The only thing you could add to this is to just tell them that your y-axis intercept, you can tell them your y-axis intercept is the point 0, -6. You can tell them that the stationary points are -312 and 1/3, -6 and 14/27. That's all you can tell them. Nice and easy. Soft. So this takes care of 2015 paper 2. I really hope it helped. All the best prepping for your exam. See you soon.